So remember when identifying the asymptotes, asymptotes are what we call non-removable discontinuities, right? We talked about asymptotes and holes last class period. Asymptotes are non-removable discontinuities, where holes are removable discontinuities. So even though we know our discontinuities is what's going to make our denominator equal to 0, we want to be careful in making sure that it's not a hole or a asymptote. So what we can do then is factor our numerator and our denominator. So if I factor our numerator, if I factor out my numerator, I factor out a 2, I'm left with x minus 4. And if I factor out my denominator, I'm left with a x minus 4 times x plus 4. That's really, really important because now you can see that the x plus 4s divide out. Since those divide out, they're not an asymptote. They're still a discontinuity, but it's not an asymptote. It's now called a hole. So anyways, to find the vertical asymptote, I'm only going to take this discontinuity and set it equal to 0. So the only asymptote that occurs is at negative 4. X minus 4 equals 0, x equals 4 is still a discontinuity, but it's a hole. Okay, so based on the question, if I said, hey, what's all the discontinuities, you'd say, oh, it's 4 and negative 4. But that's a hole, but that's an asymptote. I'm just asking for the asymptote. So that's why I like this problem, because it gives you a hole, like your homework, or like the work that we did. To find the horizontal asymptote, again, we compare the degree in the numerator compared to the degree in the denominator. Remember, whenever the degree in the denominator is greater than the degree in the numerator, y equals 0 is your horizontal asymptote. Done. And if you guys want to remember, when the degree in the numerator is greater than the degree in the denominator, the horizontal asymptote does